Hello class, welcome to Pre-Algebra Lesson 3.1, which is all about connecting ratios, rates, and unit rates. So by the end of this lesson, you should be able to use ratio concepts and reasoning to solve multi-step problems. Okay, so sorry for that typo there. But today we're going to focus a lot on unit rates, okay? So let's look at our first example. We have Nathan and Dan were both hired as lifeguards for the summer. They received their paychecks for the first week. Who earns more per hour? Okay, so let's break this down. We have Nathan. Ooh, I don't know why my tablet is being a little weird. All right, Nathan, and we have Dan. Okay, so we want to figure out who earns more. So you can see, based on this little earnings statement, Nathan worked a total of 5 hours and he earned $46.25. So how could we turn that total into letting it, like, how could we find how much he earns per hour? Well, what you do is you take the total amount that he has earned, so 46.25, and we are going to divide by 5. So 46.25, if I were to divide that by 5 on my calculator, because remember you're allowed to use calculators now, my calculator would tell me that that is $9.25 per hour. Okay? Now for Dan, I'm going to do the same thing. I'm going to take his total earnings, so that is 78.75. So 78.75, and I'm going to divide by 9 because that's the total number of hours that he has worked. Okay, so 78.75 divided by 9. If I do that on my calculator, I'm left with 8.75. Okay, so now I know how much each person earned per hour, and the question is who earns more per hour? Well, that would be Nathan, because he earns $9.25 and Dan only earns $8.75. So my answer would be Nathan. Sometimes these questions will also ask who earns more per hour and by how much, or something like that. So if you were to try to figure out how much more Nathan earns per hour, you would just do 9.25 minus 8.75, and that would be 0.50 or 50 cents, right? So you could say Nathan earns 50 cents per hour more, or Nathan earns 50 cents more per hour would be a bit better grammar. All right. So in order to find a unit rate, you do your total. Where's my pen? You do your total divided by the number of things. So total divided by the number of objects you're talking about, or items. So in this case, that would just be hours. Okay. And that's how you always find unit rate. A unit rate tells you the cost, or honestly, unit rate is usually going to deal with cost for the problems that we're doing. So it usually tells you the price for one thing. Okay, so for Nathan, the cost of 1 hour is $9.25. Okay, so why don't you try this one on your own? We have Jennifer as a lifeguard at the same pool. She earns $137.25 for 15 hours of lifeguarding. How much does Jennifer earn per hour? Good luck. All right, for this problem, hopefully you said that Jennifer earns $9.15 per hour. So you did the total amount that she earned divided by the number of hours she worked. And when you do that, you get $9.15. All right, now let's use this idea of unit rates to calculate how much dog food is needed to feed these 2 dogs for a week. Okay, so we have Brian agrees to watch his neighbor's dogs for 7 days. His neighbor provided a 128-ounce bag of dog food. Does Brian have enough food to feed the dogs all 7 days? Explain. Well, you can see we have 2 dogs. We have Buster and Roxy. So if I were to start by calculating out how much food does Buster need? So Buster I can see based on this information right over here, he eats 20.5 ounces. So that's how much he eats in 2 days. So I would do 20.5 divided by 2 in order to figure out how much does he eat in 1 day. So 20.5 divided by 2 is 10.25. Okay, so that's how much Buster eats each day. So each day. So then if I were to try to figure out how much Buster eats in a week, I would say 10.25 times 7. And when I do that, I get 71.75. And again, remember, you are allowed to use your calculator. Oops. So I wrote 71.75 ounces per week. So notice that instead of writing the word per, I just did a slash. That's another way to represent the word per. It just means that you are dividing. Okay. Then we have Roxy. We need to figure out how much does Roxy eat in 1 week. So now I'm going to write Roxy, and I can see based on the information located next to Roxy, she eats 22.5 ounces in 3 days. So I'm going to do 22.5 ounces divided by 3. And when I do that, I see that she eats 7.5 ounces each day. So then to figure out how much she eats in a week, I would do 7.5 times 7. So how much she eats each day times the number of days in a week. And I get 52.5 ounces per week. Okay, so now to figure out, do I have enough food for both dogs? All I would do is I would add those two numbers together. So I am going to take the 71.75 for Buster, and I'm going to add it to the 52.5 for Roxy. And when I do that, I'm left with 124.25 ounces. So that's the total amount of food the two dogs need for 1 week. So the question is, does Brian have enough food to feed the dogs all 7 days? So he needs 124.25 ounces, and his neighbor gave him 128 ounces. So does he have enough food? Yes, because 124.25 is less than 128. So you would say yes. And honestly, for an explanation, having this work, for me, that is good enough for an explanation. Okay, you have shown me that you know that you have to figure out how much Buster eats each week, Roxy eats each week, and then add them together and make sure it's less than what you were provided with. Okay, so I'm okay with that being your explanation. Plus, you guys need to just work on showing your work anyways, so it is kind of a win-win situation, right? All right, let's look at this next problem. We want to compare using rates. Okay, so now we are not looking at a unit rate anymore, so we're not going to have to divide and say like what each of these little jumps is. We are going to look at the entirety of what we are provided, okay? So we have, suppose that each jump covers the same distance. How many jumps does it take each animal to cover the same distance? So for the rabbit, you can see that the rabbit has jumped 3 times, and then in those 3 jumps has traveled 8 meters. So one way to know, like, is it better to use unit rates or just rates? Usually if you end up with a decimal, like it's not something nice to work with, you're going to want to use rates instead of unit rates. The only exception is when you're dealing with money. Then chances are you're going to use a unit rate anyways. Okay, so we want to see like how many jumps does it take each animal to cover the same distance. Well, I know that the rabbit jumped 3 times and reached 8 meters. The kangaroo rat I can see jumped 1, 2, 3, 4, 5 to reach 12 meters. So I am going to make a little table for each. Okay, so then I have my little kangaroo rat. The kangaroo rat jumped 5 times and made it 12 meters. Okay, so whenever you're trying to compare and find like those equivalent distances or something, what I would recommend is to start with the one that has like the bigger numbers. Okay, so in this case that would be the 5 and the 12, and I would say start changing those first. Okay, so if I know that the kangaroo rat covers 12 meters in 5 jumps, I know if he were to jump 10 times, the kangaroo rat would make it 24 meters. And now, looking at that, I'm going to, and actually, I will continue for a moment. If he were to go 5 more jumps, so 15, he would be up to, I would add 12 more again, so he would be up to 36, right? Okay, then if I go back over here for the rabbit, 3 jumps is 8 meters, so if I were to, double that, 6 jumps would be 16 meters. If I were to add 3 more jumps, that would be 9 jumps, and that would be a total of 24 meters. And right there, you can see I now have a number that matches, right? They've both end up going exactly 24 meters. Okay, so for that 24 meters, we have what we would say is how many jumps does it take each animal to cover the same distance. So the rabbit needs 9 jumps and the kangaroo rat needs 10 in order to go 24 meters. So my answer would be the rabbit needs 9 jumps and the kangaroo rat needs 10 jumps to go those 24 meters. So you can see I have it written down in the kind of lower left corner in that pink writing. Okay, so that's one way to find your find kind of like those equivalent distances. So now this one is going to be really similar. We have a kitchen sink faucet streams 0.5 gallon of water in 10 seconds. A bathroom sink faucet streams 0.75 gallon of water in 18 seconds. Which faucet will fill a 3-gallon container faster? Okay, so this one you're not looking for which one would or like when will they be equal. You're looking for which one will fill this amount of water faster. Okay, so make your tables, kind of do that same process that I did on that last slide and see what you get. Good luck. Alright, for this problem, hopefully you determined that the kitchen sink would actually fill that 3-gallon container faster. I went a little bit further in my answer, and I said specifically that the kitchen sink would be 12 seconds faster because the kitchen sink reaches the 3 gallons in 60 seconds, whereas the bathroom takes 72 seconds. Okay, so if you have questions about that, please be sure to reach out for some help. I am happy to help you. Otherwise, looking at this problem, looking at this key concept, it kind of summarizes what we have been doing in this lesson. If you have questions about that or anything else in the video, please be sure to reach out for some help. I am happy to help you. Have a great day.